In this question, it is a pretty simple question if you understand the concepts properly. In this question, it is given that a hemispherical portion of radius r is cut out from a cylinder of radius r, and this the upper surface of the cylinder is at a height h below the surface of the water, and the tension in the string is negligible. You need to find out the force on the bottom of the cylinder by the liquid. Now, for solving this question, you must understand the concept of buoyant force very clearly. If you understand what buoyant force is, this question can be solved very easily. The buoyant force acting on an object inside a liquid is nothing else but the force, the resultant of the forces acting on it due to the pressure difference at various levels. The buoyant force is the net resultant sum of all the forces acting on this object due to this liquid. Now what happens in a liquid is that the pressure at this level due to the liquid and the pressure at this level is different. In fact, the pressure in this region of the liquid is greater than the pressure at this region, and due to this pressure difference a buoyant force arises. Now in questions regarding fluid mechanics, when you apply equations in the vertical direction, you can either solve the questions using buoyant force or by the pressure difference. You can choose either method. Don't use both the things, because buoyant force is nothing else but the force due to the pressure difference. Now we need to find out the force acting on this bottom of this cylinder. So let us write this as force acting from the bottom of the cylinder minus the force acting on the top of cylinder is equal to the buoyant force. This is because the buoyant force is the net resultant force in the upward direction. The forces in the horizontal directions acting on the cylinder due to the liquid all cancel up. So the only force which is the buoyant force is the net resultant of the forces acting in the vertical direction. So the forces from the bottom will be in the upward direction minus the forces on the top due to the pressures at the various levels is equal to the buoyant force of the liquid. Now we need to find out the force acting on the bottom of the cylinder. This can be written as force on top plus Fb. Now force on top can be written as the pressure on top, that is equal to P naught, the atmospheric pressure, plus rho g into h. Rho is the density of the liquid, this is the pressure at this point, at this level in fact, into the area. Since it is a cylinder, there is a circular area of pi r square on top, plus buoyant force. Buoyant force, as we know, is always equal to the rho into volume of the submerged substance into g, that is rho into v into g. Therefore, so here if we neglect the atmospheric pressure which was given in the question, we get, I forgot to mention it in the question, but you can if by neglecting atmospheric pressure, the answer comes out to be rho gh pi r square plus rho vg. If you do not neglect atmospheric pressure, the final answer will be this. After neglecting atmospheric pressure, the final answer will be equal to rho g into v plus pi r square h. So this is the final answer for the force acting on the bottom of the cylinder by the liquid. If you would have tried to find it out directly, it would have been very difficult because the surface is not even or flat.